Hello and welcome back to this course on fundamentals of data science. Today we are going to look into these contents, which is k-means clustering, and we are going to see an example of document retrieval. The main objective for today, in detail we are going to consider what is this k-means clustering algorithm, and we are going to see some examples of how this clustering algorithms can be useful for document retrieval. So what is this k-means clustering? Well, basically it's a clustering analysis process. As the term clustering shows us that it's a task of grouping a set of objects in such a way that the objects in the same groups are called clusters, and these objects in the same group are similar in some sense to each other, to those in other groups. So you can see here clearly there is some similarity measures are needed to understand how this cluster actually functions. So that's one of the basic objective of this clustering. Let's discuss more on this point of clustering. So cluster analysis finds similarity between data according to the characteristics found in the data and grouping similar objects to a cluster. It's a process of unsupervised learning, or in other words, no predefined classes are given to us. It can act as a stand-alone tool, and it can also act as a pre-processing steps for other algorithms. So these are some of the basic things that we have to understand before we head into this actual clustering process. Actual k-means process, as we know that clustering algorithm is one of the effective process in data mining, and there are a lot of issues as far as clustering is concerned. As we can see here, because we are considering the similarity of the objects, and we are going to consider the characteristics found in the data points. So which means that we have to find some measures like Euclidean distance or other similarity measures in order to solve this problem of clustering. Well, let's move on to the details of these points. As we know that the goal of clustering is to group the data points so that the similar objects are clustered together. Identify such groups or clusters in an unsupervised manner, which means that you don't have any information about the actual labels, but still you are going to group them together. Here is an example. The results of a clustering analysis shown as the coloring of squares in 3 clusters, which means that these colors, the same colors, like for example red as a cluster, has some similarities between them. So that's one of the basic idea behind this clustering method. Let's move on and understand. Let's try to understand what is this actual process that is happening. In order to understand this, let's first discuss a little bit about this KNN, because at times many people get confused with the nearest neighbor with KNN. For example, like because there is some kind of loose relationship between k nearest neighbor classifier as well as k means clustering. So we know that k nearest neighbor classifier is kind of a popular machine learning techniques for classification as well as for grouping things in some sense. So here we should not get confused with k means due to they all have a similar name. But at times applying for example, one nearest neighbor classifier to the clustering center obtained by k-means classifies a new data into existing clusters. So before we head in, let's briefly see what is this one nearest neighbor before we go on to the actual KNN process. Suppose, for example, we are talking about retrieving data from documents. Let's say we have input query article, say A1, and your output supposed to have the most similar articles out of all the articles available in the corpus. So algorithm is very simple. You are going to search over all the articles x1, x2, x3, x4 till xn in corpus, compute x equals similarity between A1 and x1. Remember, A1 is your query article. You are going to compare your query article with the article from your corpus. So first article from the corpus is being compared. If x1 has similarity score, or x1, if x1 has similarity, then you are going to store x1, then compare with other x sub n in the corpus. Again, if x, say any x, like x21 or x31, whatever it is, if x21 is greater than, or in other words, if x21 similarity is greater than x1, then you are going to store and set x21. Right? Initially, you are going to check if x1 is similar to A1. If it is, then you are going to store x1 aside. Then you are going to compare with other articles. So at one point we may come across some article xn, let's say x21, and this similarity is greater than x1, then we are going to store x21. In other words, in this whole process, our objective is to find only one nearest neighbor, which is close to A1. Right? So here the whole process is just about finding that one, not many, just one that is very closest to this neighbor. So with this thought, let's move ahead and let's analyze further on actual observations that can be made here. Okay, let's see here. Here is the stages of clustering. There are different architecture has been proposed. Here is just a simple architecture. Once you have a pattern, the feature selection and extraction takes place. Then you are going to take out these patterns and you are going to represent this. The pattern representations are happening. Then you are going to have an inter-pattern similarity. So this process does the pattern similarity you are going to check. Then the output processes actual grouping is happening, after which you are actually getting the clusters. So this is the whole process of stages of clustering. So with the given data, in the given data you are trying to extract the features or certain characteristics of the data points, and with this data points characteristics you are going to find an inter-pattern similarity, and those similarities are calculated, and accordingly those data points which has same patterns or same similarities, they are grouped together. So that's the whole process mentioned in this whole things. Okay, coming on here to the actual k-means clustering process. So k-means clustering aims to partition n observations into k clusters in which each observation belongs to the cluster with the nearest mean, serving as a prototype of the cluster. So that's the actual process that would happen in k-means clustering. So how are this done? Basically, k-means clustering has different approaches to it. One of the method is called Forgy method, and according to this, we randomly choose k observations from the data set and uses these as an initial mean. And this is one of the assumptions that we have for the k-means clustering. The similarity matrix equals distance to cluster center. So as far as the distance to the cluster center is concerned, we expect the cluster center is smaller. The distance to the cluster center is as small as possible. Anyway, as I have mentioned, we are going to randomly choose k observations, and then these observations we are going to use it for initializing the mean. Basically what we are doing here, as we can see, you are initializing the cluster center initially with the assumptions, or we are going to choose certain k observations. So in this case we have 3: red, green and blue. And you are going to have a random partitioning method. First we are going to have a random partitioning method, randomly assigns the cluster to each observation. Here it is, assign observations to the closest cluster center. So it's done randomly, and then proceed with an update step. You are going to proceed with certain update test. So how is this actual clustering done initially? So as we have said earlier, k clusterings are created by associating every observation with the nearest mean. So the nearest mean. So initially we had k to be 3 in this example, and randomly generate these data domains. We don't know exactly how are these data points attracted towards these 3 k's. But k clusters are created in this case, that is, in this case k is 3, and every observation with the nearest mean we are going to attract those points nearest to it. So that's how the first method here. First, actually what we are doing is that we are randomly assigning the clusters to each observation and then proceed to the actual update step. So this is the initial step, which we randomly assign observation to the closest cluster center. Then you are going to compute the initial mean to the centroid of the cluster and randomly assign points. So we know that these 3 points are the cluster centers actually, and based on this cluster center we are going to take the initial mean. Then you are going to look at the actual spread, how much or how the actual spread is happening. So from the mean we are trying to find the initial mean, out of which we are going to see how the actual spread is happening. And initially, though we started with the random process, we want to understand that the actual data points that are close to this cluster center are evenly distributed. We try to understand how this data set has been taken and these data points are evenly distributed to the cluster center. So random partitioning is that what happened. So we are going to try to update this whole process. For example, initialize the cluster center. As you can see here, initially this red cluster center is assigned with this square data point, and all these square green data points are assigned to this cluster center. So with this whole process, we are going to understand how the centroid, you are going to see center of each cluster point. So this is a centroid and here is a centroid. Each cluster point centroid is being adjusted or revised. So we are going to revise it, assigning observation to closest cluster center and revising the cluster center as mean of assigned observation. So based on the mean of assigned observation, you are trying to reassign the cluster centers. So we are going to repeat this whole process of step 2 and step 3. So what we did is initialize the cluster center, assign observation to closest cluster center, then you are going to revise the cluster center mean of assigned observation. You are going to repeat this process until you converge. And if you closely look, this is your initial cluster centers, and initially what happened is that we assigned only one data point to red, right? Only one data point has been assigned to red, and the spread was in this direction for red, in the horizontal direction, whereas in green it is almost like this rectangular shape. And what happened, as we revise the cluster center by means of the mean, you are going to update the actual cluster centers. So that's where the centroid process comes in, and you are going to assign it, and then for every cluster center points, in this case all 3 cluster center points, it has been revising. You are going to actually revise the centroid, and after revision more data points are assigned to, for example, the red cluster, and the spread itself is different now. Unlike the previous shape, now the shape is completely different. So this is how the actual k-means clustering algorithm works. So based on this observation, we can actually do the whole entire process, and this is one of the basic machine learning algorithm. So we are going to do this whole process until we get converge. In other words, the centroid has to stabilize so that everything converge in one point. So right now green has 4 points, but initially, as we can see here, green has 6 points and blue had 5 points, but now again blue had 5 points. But we do see how they are shared. Okay, with this thought, let's also see how this k-means clustering is useful for any data that you have, and it also useful for easy implementation, because the process is so simple. One of the steps that we do here is just calculate the mean. As the word says, k-means, which means that the mean has to be calculated, and based on this mean you are going to actually do the clustering process. Select the k first. In this example we selected k to be 3, and select the random points, or we have to select the centroid for this k points. So we had k to be 3, and then you are going to fix what are the points that belongs to this particular 3 points, centroid of 3 points, and assign each data point to the closest centroid. You are going to assign each data point to their closest centroid. We have 3 center points are there in this case, and you can also calculate the variance and place a new centroid each clusters. In this case we are going to calculate the mean, center of the mean, and then you are going to recalculate and repeat this whole process. You are going to revise it actually So that's how this updation happens, the whole process. Now let's discuss few points on how the actual document retrieval can be done by this context. Document retrieval is defined as the matching of some stated user query against a set of free text records, and these records could be any type of mainly unstructured text such as newspaper articles, real estate records, or perhaps some records in a manual. So as we have seen earlier about document retrieval, there may be a query article and there may be several articles you may have to check, and maybe other ways you may have to retrieve a documents with several records in hand. So based on that, we'll see how this process happens. You have the input article as query articles, and the list of k similar articles are there, all the documents are there, and based on this you are going to retrieve the article that is as close as the query article. So here is a self-organizing map in text clustering context. So you have a text document and that is fed in, and you are going to identify the keywords. Then you are going to construct the feature space for that, after which the important step of similarity computation happens, and finally you are going to have the mapping documents to the cluster. As you can see, this documents are there and you are going to map with the different clusters. The similar words or text are grouped together, so which means that they are clustered and the output is the actual document clusters. Let's make it simple, like for example you are looking at an articles from sports, article from politics, articles about medicine or science and technology. So these are some of the keywords you have to identify in each of those contexts. Then you are trying to compare the you are trying to group the similarity. Similarity computation is performed. For example, all words that are related to sports go into one clusters, all words that are related to politics go into one cluster, and all words that are related to, say, weather forecast or science and technology goes into one cluster. And remember, each cluster has this so-called cluster centers. Okay, so objective is to find a similar document. Say for example, here is a document that you have in hand, and this document, say it talks about let's say it talks about football, and you have a list of documents there, and these documents may have some documents talks about politics, some talks about science and technology, and some talks about, say, football. So you have to compare each and every documents and you are trying to check the similarity index. In other words, the similarity computation takes place. So there is one example you can think about. Say for example you have coming up with the document 1 and you are comparing with a query document, and you are comparing the word similarity or word count similarities. Say for example, if this document has the word football like 5 times, and this also has say 6 times, and this has the word like goal, that's goal like say 10 times, and if it has again say 12 times the same word goal, and maybe more words you can think about like a goal and then goalkeeper, if suppose it has 4 times and 3 times. some more goalpost, for example, player, forward, all other words that are related to, say, football, football ground. You can think about soccer as well, the other word. So we find some similarities here between these words. And as we conclude from these similarities, we are going to consider they are of similar category. These words count similarity help us to understand that these two documents that we have in hand has some kind of similarities. And with this thought, we can actually group them together. If suppose one document talks about politics and other document talks about, say, science and technology, and they are no way related, and maybe the overall similarity word count may be very less. You can always think about, you can actually use these word count methods to actually sum up together and see the weights, overall weights that this two document brings in. And suppose you have a certain threshold, if suppose this document does pass the threshold, then we are going to say that they can be grouped together. And if suppose you do have, sometimes we do have some word similarities between politics and even science and technology comes in, but overall word count similarity index, when we try to calculate, maybe at times it does not fully reflect what is intended. In other words, we could say that sometimes though some articles has some similar words, only some words are similar, not necessarily many words. Here we are talking about many words. If many words are similar, then you can calculate the similarity score. Once you calculate the score, if the score is above a threshold value, then you can consider that document to be a part of what we have clustered. So that's the thought for today in this regard. So we can see that clustering is a very interesting process of machine learning, where similar objects from different groups are grouped together based on various criteria, and their application is quite wide. It's used in document retrieval, bioinformatics, text mining, city planning, pattern recognition, and various machine learning methods. So with this thought, we are going to also consider how this can be used for various applications over the many spectrum. So that was the thought for today. We talked about k-means clustering. We discussed about its applications as well, and then we talked about KNN and k-means based document retrieval. And once again, the actual k-means algorithms or k-means clustering algorithm is a very simple algorithm wherein we initially we choose k, the value of k, then accordingly you are going to consider this centroid and calculate its mean, and based on that you are going to update all those data points that are closer to the centroid. Okay, that's what we had for today, and in the next section we are going to talk about k-means clustering analysis, various different analysis method we can use for clustering. In other words, it's also can be considered as evaluation methods, and there are still different types of clustering methods available. We'll also consider what are the other types that are available. So that's it for the next session. I'm looking forward to see you there. Until then, goodbye.